Hello students, welcome back to my channel. It is always pleasure to be with you. I hope you have all seen my previous videos on combinatorics. Today we are going to start our fourth session, and in this session we are going to cover mathematical notation of combination, properties of combination, and geometrical problems. If you are new to my channel, don't forget to subscribe and press the bell icon so that whenever I upload videos like this content, you will always be notified in the first hand. If you really like my video and if you have really learned something from this lecture, don't forget to share and like the video. So let's start our journey for today's session. So today we are going to start our lecture with the meaning of NCR. In the beginning of our combinatorics lectures, I told you that combinatorics actually deals with two things. One is permutation, another one is combination. Permutation we have already done in previous lectures, where I have said that permutation deals with the arrangements and their order is important. In case of combination, it is always the selection, and here the order does not matter. Is it clear? The order does not matter in case of combination. Now, what do you mean by NCR? It means that if there are n distinct objects and out of which you are selecting r objects at a time, which can be done in NCR different ways. N distinct objects are there, out of which you are selecting r at a time. So in how many different ways you can select r objects from that n distinct objects? It is NCR. And the formula states it is equals to factorial n divided by factorial r into n minus r factorial. Is it clear? So that is what is the formula for NCR. Now observe one thing, a very important thing is that here factorial n by n minus r factorial, this is actually NPR. What is NPR? In how many different ways you can arrange r objects from n objects given. So in this case we are getting that NCR is basically NPR divided by factorial r. So that implies NPR is NCR into factorial r. It means that whenever we have done problems on permutation, we have done the combination hiddenly. Because it's a very common sense. Suppose if I say that there are 10 people, in how many different ways you can arrange 4 of them. So out of the 10 people, you have to first select 4 people, because which 4 people you want to permute. So that you have to select first, and after the selection, you will arrange those 4 people in the 4 seats or whatever. So whenever we are doing permutation, hiddenly we have actually used combination. And combination as a separate thing, you will say it is the total number of ways of selecting r objects from n distinct objects, and which is denoted by NCR. Is it clear? Now have you understood the difference between permutation and combination, as well as the relation between the permutation and combination? Is it clear? Okay, so now if I say what is the value of say 9C3? Suppose we want to find out the value of 9C3. What we will write according to the formula? it will be factorial 9 divided by factorial 3 into 9 minus 3 factorial. So that gives us what? Factorial 9 divided by factorial 3 into factorial 6. Factorial 9 can also be written as 9 into 8 into 7 into factorial 6 divided by factorial 3 into factorial 6. So this goes off. So it is 9 into 8 into 7 divided by 3 into 2. So this gives us 4. So it is 12 into 7, which gives us 84. This is the way of finding out NCR. Now, there is another shortcut tricks of finding out NC3 quickly, so that we can reduce 1 or 2 steps from here. That is, if I ask you to find out 9C3, all you will do is, you will simply write 9 into 8 into 7. Why I am writing 3 terms? Because there is 3 in the base. Is it clear? So if this 3 would have been 4, then I would have written this thing as 9 into 8 into 7 into 6. I will write 4 terms. So whatever there is in the base, you write down that much of term in the numerator, divided by whatever is given in the base. From there you write till 1. So you are going to get exactly the same answer. So it's 12 into 7, that gives us 84. So this is the shortcut way of finding out NCR. I hope now this part is very clear to all of you. Okay, what is NCR? You have understood. What is the formula for NCR? You have understood. And actually what does this NCR means? You have understood. Right? So now let us move for some problems. Before that, let us discuss some properties of NCR. NCR can also be represented as CNR. These are different ways of writing NCR. It can be written as C of N comma R, or it can be written in this way also. The meaning are all same. They are all equals to NCR. This is a different way of writing. Now, NCR, the second property. NCR is always equals to NCN minus R. NCR is always equals to NCN minus R. Is it correct or not? Now think about it. I'm showing you logically. Suppose if I ask you that there are out of 10 boys, I want in how many different ways you can select 4 boys. So you will say, sir, it is 10C4. Now, can I say this thing in other word? That when you are selecting 4 people out of this 10 people, indirectly, you are rejecting 6 people. So if this question, if I framed it differently, like in how many different ways you can reject 6 people out of 10 people. So your answer will be what? In that case, your answer will be 10C6. And this rejection of 6 people indirectly gives us the selection of 4 people. Rejection of 6 people indirectly gives us selection of 4 people. That is 10C4 and 10C6. They are same. You can check it mathematically. You can use the formula and you can check. You are going to get the same thing. But I'm trying to establish this relation logically. Is it clear? So NCR and NCN minus R, they are same. The third property states that if it is NCP equals to NCQ, if NCP equals to NCQ, then either P will be equals to Q. Obviously, if I say 10C4 and 10C4, they are same, because here the base are same as well as this 10 is also same, right? In other way, you can say in this way, 10C4 can be written as 10C, 10 minus 4, that is 6. Now, have you observed one thing? That 4 plus 6 is equals to 4 plus 6 is equals to what? 10. So what I'm saying is, when I have said NCP equals to NCQ, then you can say this thing as NCP equals to NC N minus Q. How I've written this? By using property 2. Now, P will be equals to N minus Q. As just now I told you that if NCP equals to NCQ, then P is equals to Q. So in this case also your P will be equals to N minus Q. So from here you can write P plus Q is nothing but N. So what we have learned, if NCP is equals to NCQ, then either your P is equals to Q or P plus Q equals to N. You must remember this property because objective questions can come from this part, right? The next property is NCR equals to N by R, N minus 1 CR minus 1. This is a very, very important property. Those who have already done binomial theorem, they will see that in binomial series, we used to use this property a lot. Okay, so what is NCR? It can be written as N by R, N minus 1 CR minus 1. Now you can ask me one question, sir, if I want to do it a step ahead of this, that is, I want to write this thing as N over R, it's okay. Now N minus 1 CR minus 1 is there. Can I write in this way? N minus 1 by R minus 1? Yes, you can write. In that case, you have to write this thing as N minus 2 CR minus 2. Is it clear? So this property we have to remember as NCR equals to N by R into N minus 1 CR minus 1. Now let us move for the next property, which is again a very important property. NCR by NCR minus 1 equals to N minus R plus 1 by R. Again, I'm telling you, this proof you can do it by your own. Simply by using the formula of NCR, if you put it in the left hand side, you are going to get your right hand side. But here what I am trying to teach you is how to remember this formula. Always remember that this one will be same and the base in the denominator is 1 less than the base in the numerator. Is it clear? The base in the numerator, the base in the denominator will be 1 less the base of the numerator. So what will be the answer in that case? You will simply write this N minus the base of the denominator, that is N minus R minus 1, which eventually gives us N minus R plus 1. And in the denominator you will write the base of the numerator, that is R. That is what I am saying is, if I say that NC5 by NC4, what is the answer? So here you should not go for, those who don't know the property, those who have not, who will not remember the property, he will simply use the formula here of NCR and then he will evaluate, but it will take a long time. But now what we will do, we will simply use this property. Here we see that N and N are same and the base in the numerator, and this is the base of the denominator. The base of the denominator is 1 less than the base of the denominator. Numerator. So the answer will be N minus the base of the denominator divided by the base of the numerator. That's it. So straight away we can use this formula, and that is why this property is so very important. Okay. Now let us come for the next property, which states that NCR plus NCR minus 1 is always equals to N plus 1 CR. Again, the proof of this property is pretty simple. You take the left hand side. Achha, let me just prove it. Let me just prove this one. LHS. It's NCR plus NCR minus 1. I will simply use the basic definition of NCR. Plus factorial n divided by r minus 1 factorial into n minus r plus 1 factorial. Correct? Now, I can write this thing in this way. Let me just erase this portion so that I can write it here. So I'm writing it here. What I'm doing is I'm simply writing this thing as factorial n n minus r factorial is there, so ठीक है, n minus r factorial divided by r minus 1 factorial into n minus r plus 1 into n minus r factorial, correct? So, you see, this factorial r can also be written as, r into r minus 1 factorial. So, let me just take common. Factorial n divided by r minus 1 factorial n minus r factorial. So, we are left with this is 1 over r plus 1 over n minus r plus 1, right? So from here we can write factorial n over r minus 1 factorial n minus r factorial. And if I take LCM, r into n minus r plus 1, we are getting basically in the numerator n minus r plus 1 plus r. So this r goes off. So in the numerator we are left with n factorial into n plus 1 divided by r n minus r plus 1 r minus 1 factorial n minus r factorial, correct? So this can also be written as n plus 1 factorial divided by r factorial into n minus r plus 1 factorial, and which eventually gives us n plus 1 CR. Is it clear to all? Have you understood? So this is how we prove. That is why I told you, you simply use the formula for NCR to get all those proofs. There is no big deal in it. Okay, so we have understood NCR plus NCR minus 1 is always equals to n plus 1 CR. And the last but not the least, the property states that it is NC0 plus NC1 plus NC2 till NCN. This gives us 2 to the power n. This property is well proved in binomial theorem. In binomial theorem, 1 plus x whole to the power n, if you expand that, and in place of x, if you put 1, you are going to get exactly the same answer. Is it clear? But we have to remember this. What is that? NC0 plus NC1 plus NC2 plus NC3 till NCN gives us 2 to the power n. Is it clear to everyone? Absolutely. Okay. Now let's move for the problems. Now see this question. It has been said that this ratio is given like 11:6:3, and it is said to find out the value of n and r. So now if we see this one, it is n plus 1 CR plus 1 divided by NCR, which is equals to 11/6. As we have to find out n and r, so we need two equations to solve it. So I'm trying to form two equations from this ratio. Now n plus 1 CR plus 1, this can be written as whole divided by, why it is so, which property I have used? I have used this property that NCR can be written as n by r into n minus 1 CR minus 1. So from here, NCR goes off. So we are left with n plus 1 by r plus 1 is 11/6. So that gives us, so we are actually having 6n minus 11r is equals to 5. So this is the first equation that we got. Now, the second equation I am forming by using the second part of this ratio. which is your 6 over 3, that is 2. So from here again we are using the same property and we are writing NCR as N by R into N minus 1 CR minus 1 divided by N minus 1 CR minus 1, which is equals to 2. So again this 2 goes off. So it's N over R is 2. That gives us N equals to 2R. Now let me put this value of N in the first equation. So we are having 6 into 2R minus 11R is 5. So 12R minus 11R is 5 implies R is coming to 5. And the moment we get the value of R, we know the value of N, then it is 2 into 5. So N will give us 10. Is it clear? Therefore, our answer is N equals to 10 and R equals to 5. I hope this question is clear to all of you. Pretty simple, direct application of the formula, right? Okay, let's take the next question. It has been said that evaluate this expression. The first thing is written as 47C4 plus sigma j equals to 0 to 3, 50 minus j C3. Okay, so I'm not writing this thing right now. I'm simply calculating this two first, and whatever answer we are going to have from here, we will add with the last term. So here we can write 47C4 plus 50C3 plus 49C3, 48C3 and 47C3, right? Now, if I combine these two, this one and this one, okay, so it is basically what? 47C4 plus 47C3. We know one formula. NCR plus NCR minus 1 is always equals to N plus 1 CR. So from these two, 47C4 plus 47C3, we can write this thing as 47 plus 1, that is 48C4. Am I correct? Now, the rest thing I'm writing here. Now again, if I combine this with this and applying the same formula, we are going to have 49C4, 50C3, 49C3. Is it clear? Again, I am combining this one and this one. So we are having 50C4 plus 50C3. And if I combine these two, by using this formula, it will be 51C4. Is it clear? So the first two part, if I simplify, we are going to have 51C4. Now, I have to add this with the last term. That is sigma of this thing. So let me just open this sigma. So it will be when k is 0, we are getting. Achha, let me do one thing. Before expanding this, let me use a property here and then I will expand this. Now we all know that the property NCR is always equals to NC N minus R. So that property if I use, I am going to have C minus 56 minus K minus 53 minus K. So this thing goes off. So it is basically 51C4 plus sigma. K is from 0 to 5. It is 56 minus KC3. Correct? So now let me just open the sigma. We are having 51C4 plus 56C3, then 55C3, 54C3, 53C3, 52C3, and then 51C3. Am I correct or not? Now, again, I will use this formula. I will again use this formula when we take this one and this one. So it will give us what? 51C4 plus 51C3. That will give us 52C4. Is it clear? And I'm writing the other things as it is. Now you see, if I combine this with this, so what we are going to have? We will have 53C4. Now again we combine this with this. So what we are going to have? 54C4 plus the other things remain as it is. Okay? Again you combine this and apply that property. We are going to have 55C5, 56C3, 55C3. Correct? Again you take this one and this one. I'm writing it here. So it will be again 56C5 plus, I'm sorry, one mistake I have done, 54C4 plus 54C3, that will give us 55C4, right? NCR plus NCR minus 1 equals to N plus 1 CR. So this will give us 55C4. I'm sorry in that case. Now again, 55C4 plus 55C3 will give us 56C4. Correct? Plus, we are left with 56C3. So again, it is going to give us 57C4. That's it. What we have done? We have simply used NCR plus NCR minus 1 equals to N plus 1 CR. We have simply used that and we have done this sum. So our answer is 57C4. So that's your answer. Is it clear to everyone? So let me take another problem. See this question which came in JEE Men 2021. They have said that NPR equals to NPR plus 1 and NCR equals to NCR minus 1. Now from here it's pretty simple, you see, because in the first case I have to use the formula for NPR, but for the second case no need to use the formula. You will simply say that either R equals to R minus 1, but this is not possible. Then R plus R minus 1, that will be equals to N. So from here we got one relation, 2R minus 1 equals to N. Can you remember the property? What it states, if NCR NCP equals to NCQ, then either P is equals to Q or P plus Q equals to N. That property I have used here. So when P equals to Q, R becomes equals to R minus 1, which is actually not possible. So the second thing I will use, that is P plus Q, is N. So in this case, R plus R minus 1 will be equals to N. So that gives us 2R minus 1 is N. So this is one relation we got. Now the second relation, we have been said that NPR is NPR plus 1. Now let me use the formula for NPR. This is coming like factorial N divided by N minus R minus 1 factorial. So this I can write factorial N goes off. N minus R factorial can be written as N minus R into N minus R minus 1 factorial. N minus R minus 1 factorial, correct? Now this and this goes off again. So we are left with N minus R equals to 1. Again we got another relation. Is it clear? Now we have to find out R. So let me just replace the value of N from 2 in 1. So what we are getting? 2R minus 1 minus R is 1. So R is coming to 2. Is it clear or not? Hence option C is correct. Pretty simple one. Direct application of the formula. That's what I want to show you. Because people used to forget the properties. You see, this kind of questions which came in JEE Mains, it is simply the application of properties, nothing else. Your mind is not, it is not doing something new thing here. We know the thing. If you know the property, you can do this sum. If you not know the property, then all you have to do is you have to expand the thing and then you have to, you have to get the relation. It will consume a lot of time. In that case, your property will save you. It will save you. Is it clear? Okay, let's move for the next problem. This question came in JEE Main 2024 and it has been said that 6cm plus 2 times 6cm plus 1 plus 6cm plus 2 is greater than 8c3. This is the first condition that is given. Now, again, we will use the property. The property will be NCR plus NCR minus 1 is always equals to N plus 1 CR. So in this case, we can write 6cm, 2 times 6cm plus 1 is written like 6cm plus 1 plus 6cm plus 1, 6cm plus 2. Why I have done this thing? Because I want to use this formula. So for that, I am doing it. Now I am making this thing in one bracket and I am taking this thing in another bracket. So if I use the formula here, it is NCR plus NCR minus 1. That gives us what? N plus 1 CR. N plus 1 CR. Is it clear? Plus, same thing here. NCR. This is N is 6. R is M plus 2. And R minus 1 is M plus 1. So it will be what? N plus 1 CR. So that will give us 7cm plus 2. Is it clear? See, simply by using the property, you can reduce this binomial coefficients in a very short way, right? And if you don't remember these properties, you will face problem. So in this case again, NCR plus NCR minus 1 gives us N plus 1 CR, which is greater than 8C3. Is it clear? Is this clear? Now we all know that your 8C0 is less than 8C1, is less than 8C2, is less than 8C3, is less than 8C4. And now 8C4 is greater than 8C5, is greater than 8C6, greater than 8C7 and greater than 8C8. Because in the binomial theorem, you people have all learned that the middle term of any expansion, it has the greatest binomial coefficient. So in this case, your 8C4 will have the highest, the value will be the highest among all the binomial coefficients available in 1 plus x whole to the power 8 expansion. Is it clear? That is why I have written this 8C4 is greater than all the terms below it as well as all the terms above it. Now they have said that 8cm plus 2, this is greater than 8C3. If it is greater than 8C3, then the only possibility is that your 8cm plus 2 will be equals to 8C4. See how much simple conception, basic conception they have used in this problem. It's a very, very basic conception, but you must know it. Otherwise, there will be a problem. Okay. So in this case, what you will say? You will say that m plus 2 will be equals to 4. That implies m is 2. Yes or no, tell me? Therefore, we got that our value of m is 2. Now, somebody can say, sir, why you have taken this one? Why not this? P plus Q is your n. Because what we know, if NCP is NCQ, then either P is equals to Q or P plus Q equals to N. But from here, you are again going to get the same value. There will be no change. Okay, so we got the value of M as 2. Now, we have to find out the value of N. For that, the second relation is given to us. N minus 1 P3 over n P4 is 1 over 8. So from here we can write n minus 1 factorial divided by n minus 4 factorial divided by factorial n divided by n minus 4 factorial. I've simply used the formula for NPR. So this one goes off. So we are left with n minus 1 factorial divided by factorial n is 1 over 8. So from here we can write n into n minus 1 factorial is 1 over 8. So n minus 1 factorial goes off. So 1 over n is 1 over 8 implies n is 8. Correct? So we got n equals to 8 and m equals to 2. Now we have to find out the value of npm plus 1, n plus 1 cm. So let me just put the values. N is 8 and m is 2. So it is 8p3. The formula is factorial 8 divided by 8 minus 3 factorial. That gives us factorial 5 plus 9 into 8 divided by 2 into 1. So it gives us 8 into 7 into 6 into factorial 5 divided by factorial 5 plus 9 is a 72 divided by 2 is 36. So that gives us, this is 8 into 7 6 are 42 plus 36. So that gives us 336 plus 36, so that gives us 372. Hence, option D is correct. Is it clear to all? So what I have done, I have simply applied the properties. Again and again I am telling you, please do remember all the properties. It will help you a lot in solving this kind of problems. And you can see, on the basis of these properties, JEE people are giving problem every year. So you must remember the properties by heart. Okay? Let's move for the next problem. This question came in 2024. It states that n minus 1 CR is k square minus 8 into NCR plus 1. Now, you have to find out the range of K. You have to find out the range of K. So, what to do? I can write K square minus 8 into, this thing can be written as the property what we know. Again, I am writing it. So, I can write in this thing, in this way, n by r plus 1 into n minus 1 CR. So now cancel this thing from both sides. We are having r plus 1 by n is k square minus 8. And we all know that from the given equation, n minus 1 will be greater than equals to r and n will be greater than equals to r plus 1, right? So from here we are getting n is greater than equals to r plus 1. So r plus 1 by n is less than equals to 1. Same thing from here also. Okay. So your r plus 1 over n is less than equals to 1. Definitely this is greater than 0. Okay, because n and r both are positive. So they are greater than 0. So now r plus 1 by n is basically k square minus 8. So from here we can write k square is lying between 8 and closed 9. So from here we can say k is lying between this or minus 3 less than equals to k less than minus 2 root 2. Is it clear? Therefore the option A is correct for this question. Yes. Have you understood this? See, again what I've done. I've simply used the property. Simply use the property. That's what I want to show you every time. That please do remember properties. Okay? So let's move for the next problem. See this question. A person is permitted to select at least one coin and at most n coins from a selection of n distinct coins. So there are n distinct coins. There are n distinct coins, and from which the person is permitted to select at least one coin and at most n coins. If the total number of ways in which he can select coins is 511, find the value of n. How to do this sum? Now the person is permitted to select at least one coin and at most n coin. Now how many number of coins he is selecting at a time? He can select one coin, he can select two coins, he can select three coins. At the same time, he can select n coins. So these are all the possibilities that the person has to select coins from the given n distinct coins. Is it clear? So one coin can be selected from these n coins in NC1 different ways. Two coins can be selected in NC2 different ways. Three coins can be selected in NC3 different ways. And this thing goes on. And n coins can be selected in NCN different ways. So total number of ways the person can select at least one coin to at most one coin is this. Yes or no? The sum of all this will give the total number of ways the person can select one coin, minimum one coin and maximum n coins. By the problem they have said this is equals to 511. Now we have learned again the property. We have learned the property NC0, NC1, NC2, NC3, this thing goes on till NCN is basically 2 to the power n. So this much will give us what? It is nothing but, if I say this is S, so this S is nothing but 2 to the power n minus NC0. And NC0 is basically 1. Therefore, we can write 2 to the power n minus 1 is 511. So from here we can write 2 to the power n is 512. So that gives us 2 to the power n is 2 to the power 9, implies n is nothing but 9. Is it clear or not? Is this clear or not? See, again the use of property. NC0 plus NC1 plus NC2 plus NC3 dot 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 till NCN will give us 2 to the power n. That's exactly what we have used. Now those people who have already done binomial theorem, they are very, very, familiar with this property, because this property is widely used in binomial series. Okay, let's move for the next problem. See this question. How many distinct handshakes can occur if there are 20 people at a party and each person shakes hands with every other person exactly once. So there are 20 people. Now, if we know how many ways are there of selecting 2 people out of these 20 people, then every selection of 2 people, we will get 1 handshake. We will get only 1 handshake. So how many number of such handshakes will be there is equals to the total number of ways of selecting 2 people out of that 20 people given. Is it clear? So total number of handshakes for the first problem will be 20C2, and that gives us 20 into 19 divided by 2. So 10 into 19 gives us 190, and that's the answer. Is it clear? Every person is going to shake hands with each and every other person only once. So the total number of ways of these handshakes will be same as the total number of ways of selecting 2 people at a time. Because 2 people is going to go for a handshake only for 1 time. Is it clear? Okay, let's see the next problem. How many ways can 4 books be chosen from a shelf of 10 different books? Straightforward question. 10 different books are there. You are going to select 4 books out of it. So it can be done in 10C4 different ways, which is actually 4 2s are 8, 3 3s are 9. So this gives us 10 into 21 gives us 210. So there are 210 ways of selecting 4 books from 10 different books in the shelf. Next point, a pizza shop offers 6 toppings. How many ways can you select 3 toppings from a pizza? For a pizza, you have to select 3 toppings. In how many different ways you can select these 3 toppings from 6 toppings available? Straightforward question again. 6 toppings are there and you want to select only 3. So total number of ways of choosing the toppings will be 6C3. It is 6 into 5 into 4 divided by 3 into 2. So that gives us 20 ways. Is it clear? Next question. Now there is a group of 5 men and 8 women. So this is the group from which I have to select 2 men and 3 women. In how many different ways I can select this? So 2 men will be selected from this 5 men. It can be done in 5C2 different ways. And 3 women can be selected from 8 women, which can be done in 8C3 different ways. So the total number of ways of selecting 2 men and 3 women will be 5C2 into 8C3. So that will give us 5 into 4 divided by 2 into 1 into 8 into 7 into 6 divided by 3 into 2 into 1. So that gives us actually 10 into 56. So there are total 560 ways are there. Is it clear to all? Have you understood? These are all basic sums from combination. But these are the good sums to understand how the combination is actually, we are using it. Whenever there is a question of selection where order is not important, we will always go for combination. That's exactly what we have done in those sums. Okay, let's move for the next problem. In how many ways a team of 6 will be selected from 8 boys and 6 girls? So there are 8 boys and 6 girls, out of which a team of 6 is to be selected. Okay? In how many different ways you can do that? Where number 1, exactly there will be 3 boys. So what is the first question? Exactly there will be 3 boys. So there will be 3 boys. We want 6 people. So 3 boys are already there. So I need only and 3 girls. So that can be done in 8C3 into 6C3. So that will give us so 6 goes off, again 6 goes off, so it is coming like 56 into 20, so that gives us 1120 ways. So exactly 3 boys can be selected in 1120 ways. Is it clear to all? Is this clear to all? Okay, so now next question. Now the question is, at most 3 boys, at most 3 boys. At most 3 boys means maximum you can choose 3 boys. Now what are the options available? This is for question number 2. This is boy and let us say these are the girls. So at most 3 boys. So if 3 boys are selected, so 3 girls will be selected because I need total of 6. Now if boys are 2, then girls will be 4. If boy is 1, the girls will be 5. And if there is no boy, all girls will come. I mean, all 6 will be girls. So total number of ways is, for the first case, it will be exactly the same thing that we have done. The answer will be 1120. I am not going for the calculation again. For the second case, it will be 8C2 into 6C4. So 8C2 is basically 8 into 7 divided by 2 into 1 into 6C4 is same as your 6C2. That is 6 into 5 divided by 2 into 1. Have you understood this? Because NCR is same as NCN minus R. So 6C4 is same as 6C2. So it can be written as 6 into 5 by 2 into 1. So that's 4, 3. So it is coming like 28 into 15, so that gives us 420. And next case is 1 boy. 1 boy will be selected from, let me do it here. 1 boy will be selected from 8 boys. That can be done in 8C1 different ways. And 5 girls are to be selected from 6 girls, which can be done in 6C5 different ways. So that will be 8C1. Again, 6C5 is same as your 6C1. So it is coming like 8 into 6. So answer is 48. And for the last one, no boys are selected, all 6 girls are selected. So that can be done in 66 different ways, that is 1 different way. Therefore, the total number of ways will be, for the second case, 1120 plus 420 plus 48 plus 1. So that gives us 1589. So that is the answer for the second one. Is it clear? Now, the third question. At least 3 boys. At least 3 boys means कम से कम 3 boy होना चाहिए. So at least 3 boys means there will be minimum 3 boys present. So what are the options again? Boys and then girls. Let us consider 3 boys, then 3 girls, 4 boys, 2 girls, 5 boys, 1 girl, and 6 boys, no girls. Okay? So again, 3 boys and 3 girls, they can be selected in 1120 different ways. This I have already calculated. For the second one, it will be 8C4 into 6C2. So it is coming like 8 into 7 into 6 into 5 divided by 4 into 3 into 2 into 1. 6C2 gives us 6 into 5 divided by 2 into 1. So 4 to 8, 3 to 6. This is 3. So it is coming like 14 into 5 into 15. So it is coming like 14 into 75. That gives us 1050. Okay. Now, what about the third case? It will be 5 boys selected from 8 boys. So it is 8C5 into 1 girl. 6C1. So that gives us 8C5 is same as 8C3 into 6C1. That gives us 8 into 7 into 6 divided by 3 into 2 into 6. So that gives us 56 into 6, which gives us 336. Okay? And the last one is 6 boys are to be selected. No girls are selected. So that can be done in 8C6 different ways, which is same as your 8C2. So that gives us 8 into 7 divided by 2 into 1. So it is coming like 28. So the total number of ways where at least 3 boys will be there will be, let me write it here. It's 1120 plus 1050 plus 336 plus 28. And that gives us 2534. Is it clear? So through this question, we have understood one very important, thing. That is, whenever they are saying for at least and at most, you should be very careful. At least means minimum that amount should be there. Here they have said at least 3 boys. It means what? Whatever group you are forming, at least minimum 3 boys should be there. And if I say at most 3 boys will be there, it means what? Whatever group you are forming, maximum number of boys that you can include is 3. Is it clear? So at least and at most, these 2 words you should be careful about whenever it is given in the question. Okay, let's move for the next problem. So this question, which came in JEE Main 2021. A scientific committee is to be formed from 6 Indians and 8 foreigners. Which includes at least, be careful, at least 2 Indians. Means whatever group you are trying to form, at least 2 Indians should be there. And there is a condition for the foreigners to be included, is that how many the number of Indians that are involved in the group, the foreigners number will be simply the double of that. Is it clear? So now let us just find out the cases. Case 1, listen it carefully. This is Indian and this is foreigner. So let me choose 2 foreigners. Sorry, 2 Indians. If 2 Indians are selected, naturally double the number should be there for the case of foreigners. So foreigners here will be 4. Case 2. Let us say Indians be 3. 3 Indians are there in the committee. So naturally the foreigners will be 6 foreigners will be there. Because double the numbers every time. Case 3. If 4 Indians are there, so then there will be 8 foreigners. Now no more case will come here, because if I choose that 5 Indians will be there, so in that case there should be 10 foreigners, but only 8 foreigners are available to us to form the committee. So no more cases will be formed. The total number of ways for this case will be 2 Indians, 6C2, and 4 foreigners, it's 8C4. For the second one, we will get 6C3, 8C6. And for the third case, 4 Indians, 6C4, 8 foreigners, 8C8. So total number of ways of forming the committee will be this plus this plus this. Okay, so let me just go for the calculation. 6C2 into 8C4, 8 into 7 into 6 into 5 divided by 4 into 3 into 2, 8 goes off, 2, so it is basically 15 into 70, right? So that gives us 1050. Case 2. Again, 8C6 is same as your 8C2. So it is now coming to 20 into 28. That gives us 560, right? Now the case 3, it is saying 6C4 into 8C8. 6C4 is same as 6C2, which is 6, and 8C8 is basically 1. So 6C2 is 6 into 5 divided by 2 into 1. That gives us 15. Therefore, the total number of ways will be 1050 plus 560 plus 15. So that gives us 1625. Hence, option B is the correct one. Have you understood this problem? Simple. Again, in this question, I'm showing you all the questions which came in JEE Mains. It's not I have chosen those sums arbitrarily. No. These all questions came in JEE so that you can understand the type of questions JEE people used to ask in the examination. Okay. Every basic thing you must know because they can ask you questions from anywhere. So be careful. Don't try to leave any part of any chapter. That is the, will be the recipe for disaster. Okay. So in this question, again, the word at least was there. At least 2 Indians should be in the committee. So we have done the sum accordingly. We have considered all the cases and then we have added up all the cases. We got the answer. Is it clear? So from that point, this question is pretty simple question asked in JEE. Okay, let's move for the next problem. This question came in JEE Main 2021. They have said that there are 15 players in a cricket team, out of which there are 6 bowlers, 7 batsmen, and 2 wicket keepers. Okay? Now we have to make a team of 11 players in such that it will include at least 4 bowlers, 5 batsmen, and 1 wicket keeper. That's the question. So let me make some cases first. I have to make a team of 11 players. So let us make cases. This is bowler, batsman, and this is say wicket keeper. So case 1, at least 4 bowlers will be there. At least 5 batsmen will be there. So we have, and at least 1 wicket keeper will be there, but we have to make a team of 11. So 2 wicket keepers will be included. Case 2. I have included 5 bowlers, but 5 batsmen are there and 1 wicket keeper is there. So total is 11. Case 3. 4 bowlers are there, but we have taken 6 batsmen and 1 wicket keeper. Now, other than this, do you think that any other group can be formed or any other team can be formed where there will be at least 4 batsmen, at least 4 bowlers, 5 batsmen and 1 wicket keeper? No. So these are the 3 cases possible to form the team under the required restriction which is given to us. Therefore, the total number of ways of forming such team will be, for this one it will be 4 bowlers, so 6C4 and 5 batsmen, that is 7C5, and 2 2 wicket keepers, it will be 2C2. Case 2 is 6C5, 7C5 and 2C1. And case 3 is 6C4, 7C6 and 2C1 again. So total number of ways of forming this team will be the sum of all these 3 cases. Now one by one, let me just solve it. So it is 6C4, which is same as your 6C2 into 7C5. I'm considering the first case, 7C5 is same as your 7C2 and 2C2 is basically 1. So this will give us so it is coming to 15 into 21, that gives us 315. Now let us consider case 2. 6C5 is same as your 6C1. I hope you are all understanding why I'm taking in this way. Because the formula is, the properties is NCR is same as NCN minus R. So 6C5 can be written as 6C1 into 7C5 can be written as 7C2 and 2C1 is 2. So this is 6, 7 into 6 divided by 2 into 2. So that gives us 6 into 42, which is actually 252. And now we are considering case 3, which is 6C4. Again, 6C4 can be written as 6C2, 7C6 can be written as 7C1, and 2C1 can be written as 2 only. So 6C2 is basically 6 into 5 divided by 2, 7C1 is 7, and this is 2. So it is coming to 15 into 14, that gives us 210. Therefore, the total number of ways of forming this team will be 315 plus 252 plus 210. So that gives us 777. Is it clear? Have you understood this problem? Again, it's a problem of at least taking something. A restriction is given to you. Is it clear? So accordingly, you make the cases. Whenever at least and at most are there in the question, always make the cases. And then you find out, you calculate all the cases, and then you sum it up. Exactly the same thing what I have done here. Is it clear to all? Let's move for the next problem. See this question. There are 10 boys and 5 girls. Then the number of ways of forming a group consisting of 3 boys and 3 girls. If both B1 and B2 together should not be the members of a group. You have to form a group consisting of 3 boys and 3 girls from the available 10 boys and 5 girls. But be careful, B1 and B2 will never be together in the group. It means what? That when B1 is there, B2 is not there. When B2 is there, B1 is not there. Or the other case will be, I have not selected B1 as well as B2. Both of them are not selected. So there will be 3 cases. Case 1. When B1 and B2 are not in the group. So you have to take 3 boys and 3 girls. So 3 boys will be taken from these boys. There are 10 boys in which there are 2 people, B1 and B2. And I'm not selecting these 2 boys in my team. So what I will do, I will simply reject these 2 people. And now we are left with only 8 boys. Out of that 8 boys, you select 3. Okay? Now I need 3 girls. This is the number of ways in which you have selected 3 boys, rejecting B1 and B2. Now you have to select 3 girls. 5 girls are available. So out of 5 girls, I will select only 3, which can be done in 5C3 different ways. Okay, case 2. B1 included, B2 excluded. So B1 is already in my team. B1 is already in my group. B2 I will not select. So now, the available boys, how many available boys were there? Actually 10. B1 I have already taken. B2 I will not take. So there are 8 available boys, out of which you have to select 2 boys. Yes or no? Because you have to select 3 boys. 1 boy B1 you have already taken. So you need 2 more boys. From where you will take it? From that 8 boys available. So boys can be selected in 8C2 different ways. And girls, there is no problem. I have selected 5C3. I mean 3 girls has been selected from a group of 5 girls. So it can be done in 5C3 different ways. So the total number of ways in which B1 is included but B2 is excluded is 8C2 into 5C3. Now case 3. Here B2 is included, B1 excluded. So what will happen? I will take B2. First, I have taken B2. In my group, I have already taken B2. I have rejected B1. So now, how many boys are available to you now? B2 you have already taken, B1 I will not take. So you are left with 8 boys. And again, from these 8 boys, you need 2 boys. Because I need 3 boys. B2 is already in my group, so I need 2 more boys. So that can be done in, again, 8C2 different ways. And in case of girls, we don't have any problem, so it will be 5C3. So total number of cases for this sum will be 8C3 into 5C3 plus 8C2 into 5C3 plus the same thing 8C2 into 5C3. I have simply added these 3 cases. So let me calculate this one. 5C3 is same as 5C2. So it will be 5 into 4 divided by 2. 8C2 is 8 into 7 divided by 2. 5C3 again, it is same as 5C2. So it will be 5 into 4 divided by 2. And this thing, they are same. So I'm simply multiplying this with 2. So we are having actually 56 into 10 plus 2 goes off. This 2. So it is 56 into 10. So we are actually having 560 plus 560. So that gives us 1120. Is it clear to all? So in this question, again a restricted permutation is given. And this sum came in JEE Mains. So you can understand the kind of questions that they are asking. Definitely there will be some restriction because the problem cannot be very simple like in how many different ways you are choosing 4 books from 10 books. That sums we have done to make you understand the application of the formula. But this kind of problems will not come in JEE Mains. In Mains, they will always give you some restriction. In this case, the restriction was that you have to select 3 boys and 3 girls. But remember, B1 and B2 are the 2 particular person. I will not take these 2 boys in my group at a time. So what are the cases that I've considered? I've considered that B1 is coming, B2 is not coming. B2 is coming, B1 is not coming. And then I have rejected both B1 and B2. So these are the 3 cases. So I have simply added those cases to get my final answer. That's it. Is it clear? Okay. So let's move for the next part. So geometrical problems in combinatorics explore the intersection of geometry and combinatorics, focusing on counting, arrangement and configuration problems in geometric spaces. These problems typically involve discrete objects such as points, lines, planes or shapes like polygons or polyhedra, and aim to understand how they can be arranged, combined or relate in various ways while respecting certain geometric constants. Okay, now see this question. There are 10 points on a plane. Out of this, no 3 points are on the same straight line except 4 points which are collinear. What do you mean by that? There are 10 points on a plane, out of which no 3 points are on the same straight line, means no 3 points are collinear, except 4 points. Out of these 10 points, there are 4 points which are collinear. Other than that, no points are collinear, right? Now the question is, how many straight lines can be formed? Tell me one thing. If you have points on a plane, and if you want to draw a straight line, what do you need? To draw a straight line, I need 2 points. I need 2 points. The moment I get 2 points, a straight line can be drawn passing through these 2 points, right? So now, let me just try to draw the figure. There are 4 points which are collinear, that is, they are lying on the same straight line. And there are 6 other points outside which are not collinear. Okay? Now, this is method 1. Method 1, I am trying to do it. Then I will do a second method also. Now, for a time being, let me just forget about these 4 points which are collinear. So we are left with only 6 points. And from these 6 points, if I ask you how many number of straight lines you can draw, you will say, sir, the number of straight lines will be equals to the number of ways of choosing 2 points. Because as I told you that through 2 points you can draw one straight line. So the total number of ways you can select 2 points is equals to the total number of straight lines that can be formed. Now, there are 6 points and you are choosing 2 points out of it. So how many number of straight lines that can be formed? It is 6C2. Is it clear? It is 6C2. So 6C2 number of straight lines can be formed by these 6 non-collinear points. Now listen it very carefully. Through these 4 points which we have rejected previously, through these 4 points you can draw one straight line. Through these 4 points which are collinear, one straight line can be drawn. So total number of straight lines will be 6C2 plus 1. But wait, yet the game is not over. Now, if I choose this point, I can draw 6 more lines with the points which are not collinear. That is, I can draw the line like this, I can draw the line like this, another line can be this, another line can be this, another line can be this, as well as this. So through this point, if I consider one of the collinear points, you can draw 6 more lines with the other non-collinear points. So we are having 4 such collinear points. So total number of straight lines that can be formed using one of the collinear points and 6 other non-collinear points will be 4 times 6. Because for every point you are going to have 6 lines. So there are 4 points, you are going to have 4 into 6 number of other straight lines. Is it clear? Therefore, our answer will be 6 into 5 divided by 2 plus 1 plus 24. So it is 15 plus 1 plus 24. So that gives us 40. Is it clear to all? What I have done in method 1? I have separated the 4 collinear points. Now I have forgotten that. Now to me, we are having 6 non-collinear points. Through these 6 non-collinear points, how many number of straight lines we can draw? First, we have calculated that. We know that for a straight line, I need 2 points. So from these 6 points, in how many different ways you can choose 2 points? That can be done in 6C2 different ways. Okay. Now, there are 4 collinear points. Through that 4 collinear points, you can draw one line. So that line has to be calculated. I mean, it has to be taken into our account. Another one, the last part is that if I choose any one point of this collinear points, from there you can draw 6 more straight lines. 1 point from the collinear points and the other point from any of the non-collinear points. So through one collinear point, you are drawing 6 lines. So we are having 4 such collinear points. I mean the 4 points which are collinear. So total number of straight lines which can be formed is 4 times 6. So total number will be, as we have calculated, 6C2 plus 1 plus 6 into 4, that is 24. So we have calculated it to 40. Have you understood this? This is one way of doing the sum. Now I am trying another way. Let us consider, they have said that these 4 points are collinear. I am saying no points are collinear. So we are having 10 points. From these 10 points, if I ask you if no 3 points are collinear, what you will say? The total number of straight lines that can be formed will be 10C2. Tell me yes or no? If these 4 points are not collinear, you are having 10 points. So from that 10 points, how many number of straight lines you can draw? The number of ways in which we can choose 2 points out of these 10 points. And that can be done in 10C2 different ways. So total number of straight lines so formed is 10C2. Now, these 4 collinear points has already been considered as non-collinear, but actually they are collinear. Now let me just see how many number of straight lines that can be drawn by taking only these 4 points. If these 4 points would have not been collinear, how many number of straight lines you can form? It is nothing but 4C2. Am I correct? Now this number of straight lines is already involved in 10C2 calculation, because there we have considered that no points are collinear. But no such straight lines will form. The total number of straight lines that is formed, which is 4C2, will actually not form a straight line because they are collinear. So I have to subtract those amount of lines which has already been calculated in 10C2. But one thing for sure, that there will be one line passing through these 4 points. So I must add 1 there. Is it clear? I have considered that these 10 points are not collinear. No 3 points are collinear. So 10 points, through these 10 points, if you want to draw straight lines, you need 2 points. In how many ways you can draw? You can choose 2 points out of these 10 points. It's 10C2. Now the 4 points which are actually collinear, which in our case I have said that they are not collinear. If they would have not been collinear, how many number of straight lines you will form from these 4 points? It is 4C2. So this amount 4C2 is actually 6. So the 6 straight lines we have already considered in 10C2. That has to be subtracted because no such lines are formed. So I have subtracted that. But one thing for sure, that one line will definitely pass through that 4 collinear points. So that point has to be taken into consideration, and that is the reason why I have added 1 at last. So the total number of lines that can be formed is 10 into 9 by 2 into 1 minus 4 into 3 divided by 2 plus 1. So that gives us, this is 45 minus 6 plus 1. So that gives us 40. Is it clear? So these are the two ways. Whichever way you feel comfortable, you can do it. Right? Let us see the next question. So number of straight lines, answer is 40. Now, next question is, how many number of triangles can be formed? Again, very interesting. I will use here method 2. I will say that, well, these 4 points are collinear. Now, other 6 points, they are not collinear. So let us assume that no points are collinear in the system. So 10 points are available to us. Now, how many number of triangles can be formed by taking all those 10 points? Now, to draw a triangle, you need 3 points. So the total number of ways where I can select 3 points out of these 10 points will be equal to the number of triangles formed. So the total number of triangles that will be formed is basically 10C3. When we have considered that these 4 points are not collinear, but actually they are collinear. So if these 4 points would have not been collinear, then how many number of triangles can be formed by these 4 points? It will be 4C3. But no such triangles will be formed because these 4 points are collinear, which have already calculated in this value. So I have to subtract those triangles which has been created falsely. Therefore, the total number of triangles that can be formed is 10C3 minus 4C3. Now, through these 4 points, you cannot draw any single triangle. In case of straight line, you have drawn one straight line passing through these 4 points. But it is not possible to draw a triangle by taking these 4 points which are collinear. So that is why here I have not added anything. So what will be the answer? 10 into 9 into 8 divided by 3 into 2. 4C3 is same as 4C1, which is 4 only. So it is 15 into 8 minus 4. It's 120 minus 4. That gives us 116. Is it clear? 116. Now, the third question. How many number of quadrilaterals can be formed? Quadrilaterals. So to draw a quadrilateral, you need 4 points. If you give me 4 points, I can draw a quadrilateral. Okay. Now you see, these 4 points are collinear. And these 6 points are non-collinear, right? Now to draw a quadrilateral, let us first assume that we are choosing 4 points from these 6 non-collinear points. So from the 6 non-collinear points, how many ways are there of choosing 4 points? It's 64. So 64 number of quadrilaterals will be formed simply by using all these 6 non-collinear points. Is it clear? Now, let me take 1 point from this collinear point. Only 1 point. Which point? 4C1. Any of this point I am choosing, and that can be chosen in 4C1 different ways. The other 3 points I am choosing from these non-collinear points. that can be chosen in 6C3 different ways. So the total number, the number of quadrilateral that will be formed simply by taking 1 point from this collinear point and 3 points from this non-collinear points in 4C1 into 6C3 different ways. Okay. Now let us choose 2 points from these 4 collinear points, which can be done in 4C2 different ways. Now, 2 other points I am choosing from these 6 non-collinear points. So that can be done in 6C2 different ways. 2 points I have chosen from the collinear points, which can be done in 4C2 different ways. Now I need 2 more points, and these 2 points I have chosen from 6 non-collinear points. So the total number of quadrilateral that will be formed where the 2 vertices will lie on these 4 collinear points. Okay? So it will be 4C2 into 6C2. Now no more selection I can do, because if I choose 3 points from these 4 collinear points, you cannot form a quadrilateral. So the 2 options were there and we have taken that 2 options. The first option was I have chosen 1 point from these 4 collinear points and 3 points from these non-collinear points. And the second option was I have chosen 2 points from these 4 collinear points and 2 points from these 6 non-collinear points, which can be done in 4C2 into 6C2 different ways. So total number of quadrilaterals that can be formed is this one, which is actually equals to 6C4 is same as 6C2 plus 4 into 6 into 5 into 4 divided by 3 into 2 plus 4 into 3 divided by 2 into 6 into 5 divided by 2. And 6C2 can be written as 6 into 5 divided by 2 plus this thing goes off. It is 2. This is 2. 2 to 4. So we are left with 4 into 20 plus 30 into 3, that is 90. So it is 15 plus 80 plus 90. So that gives us 185. So total 185 number of quadrilaterals can be formed in this scenario. Have you understood the problem? When we have considered straight line, I have done it by 2 methods. I hope you have understood. If not, please rewind this video after this live class and then you can see this one again. Then we have considered how many number of triangles will be there. And the last problem was how many number of quadrilaterals you can form. So what I have done, the first step I have done is, I have chosen these 4 collinear points I have forgotten. So we are having only 6 non-collinear points. Through these 6 non-collinear points, if you want to draw a quadrilateral, that can be done in 6C4 different ways. Because to draw a quadrilateral, you need 4 points. Clear? So 6C4. Now next is, I am choosing 1 point from that 4 collinear points and 3 points from this non-collinear points. So that can be done in 4C1 into 6C3 different ways. Now I am choosing 2 points from the 4 collinear points and 2 points from this 6 non-collinear points. So 2 points from the collinear points can be chosen in 4C2 different ways, and 2 points from the 6 non-collinear points can be chosen in 6C2 different ways. So total number of triangles will be, simply add all those cases. You see, apart from that, you don't have any other option to form any quadrilateral in this scenario. Is it clear? So let's move for the next problem. This is our answer, 14, 116 and 185. In this question, they have said there are n points on a plane. Out of these points, no 3 points are collinear. I mean, all the n points, no 3 of them are collinear. how many point of intersection is possible? The first question is, to get a point of intersection, to get a point of intersection, you need two lines. So first of all, to find out the number of point of intersection, we have to find out how many number of straight lines are there. How many number of straight lines are there? Now, out of that straight lines, if you take two straight lines, out of that straight lines, if you take two straight lines, every time you are going to get one point of intersection. Tell me yes or no. So there are n points in a plane, out of which no 3 points are collinear. So number of straight lines that can be formed is NC2. Tell me yes or no. NC2. So this is the total number of lines which is formed. Let me denote this by capital N. Now the question is, how many number of point of intersections possible? So from these n straight lines, you have to choose two straight lines. Because for any two straight lines, you are going to have one point of intersection. Tell me yes or no. Therefore, the total number of point of intersection, total number of point of intersection will be what? It will be NC2. What is capital N? It is the total number of lines that are formed when n points are given and no 3 points are collinear. So total number of straight lines from capital N. Now to find out the point of intersection, what I will do? I will choose two straight lines out of this capital N straight lines. Because for any two straight lines, we are going to have one point of intersection. Tell me yes or no. Therefore, the total number of point of intersection will be capital NC2. So that's your answer. Is it clear? This is not small n, this should be capital N. Okay, and what is capital N? It is basically NC2. So this is the total number of point of intersection we will get. Okay, let's move for the next problem. This question came in JEE Main 2021. They have said if the sides of a triangle ABC, let me just draw the triangle first. So this is ABC triangle in which there are 3 points on the side AB. There are 5 points on BC. And there are 6 points on CA. Okay. The question is then how many number of total triangles that can be constructed using these points as vertices? Is it clear? Simple sum. Simple sum. You have to draw triangles by using those points on the sides of this triangle given. So let me do one thing. First, let us consider any point on AB. Any one point on AB. And any one point on AC. And any one point on BC. So what I've done, 1 point on AB and 1 point on AC and 1 point on BC. So a triangle will be formed. Now, in how many different ways you can select one point on AB? On AB there are 3 points. So it will be 3C1 into AC is having 6 points. So 6C1 and 1 point on BC. BC containing 5 points. So 1 point can be selected in 5C1 different ways. So the total number of triangles that will be formed is 3C1 into 6C1 into 5C1. This is the triangle which is formed where you have taken one vertices on each side of the triangle. Clear? Now, let us choose 2 points on AB and 1 point, any point I must write, any point any other point. Okay? Is it clear? What I'm doing? I am choosing 2 points from AB and choosing any 1 point from the points which are on AC or BC. Because if you choose any 1 point from these two, and if you choose 2 points on AB, you are going to form a triangle whose one side will be on AB. Is it clear? So that can be done in 3C, 2 different ways. That is choosing 2 points out of these 3 points on AB. And how many points are there on AC and BC? Total is 11. So from that 11 points, you simply choose 1 point. Is it clear? So that is the total number of triangles that are formed whose one side coincides with the side of the triangle AB. Now the same thing I will do. I will choose 2 points on AC and any other point. So your AC is having 6 points. So 2 points can be selected in 62 different ways. And the other points are 8 points, out of which you are choosing only 1 point. So this will be the total number of triangles formed whose one side will coincide with the side of the triangle ABC. And that side is AC. Is it clear? Now let me choose the last case. 2 points from BC and any other point. Now your BC is having 5 points. So 2 points can be chosen in 5C, 2 different ways. And the other points which are left are 6 plus 3, that is 9. So from that 9 points, I am going to choose only 1 point. Is it clear? Therefore, the total number of triangles, so formed will be what? 3C1, the first case. This is the first case. So it is 3 into 6 into 5. This is the second case. 3C2 is same as 3C1. So it will be 3 only, and 11C1 is 11. Now this is our third case, which is 6C2. That is 6 into 5 divided by 2 into 8C1. 8C1 is 8. And this is our fourth case, which is 5C2 into 9C1. 9C1 is 9 only. So let me just calculate this. 5, 6 are 30, 90. This is 33 plus 4. So it is coming like 6 into 20, right? 6 into 20, that is 120. And this is again coming to 90. So it is coming like 180 plus 120 gives us 300 plus 33. That gives us 333. Hence, option C is correct. Have you understood the problem? Simple sum. Simple. You have to simply make the cases and you have to add all the cases to get the total number of triangles so formed. That's it. You see, there are two options. You choose 1 point each from every side of the triangle so that the triangle so formed will have no of its sides common to the sides of the given triangle ABC. This is one case. And another case is, in another case, you have three subdivision. In that way, you choose a triangle whose one side will coincide with AB. Triangles which one side will coincide with AC. And the triangles whose one side will coincide with BC. That's exactly what I've done. Triangles whose one side will coincide with AC. What I've done, I've chosen 2 points from AC and 1 point from the rest points. So I'm going to get a triangle whose one side will coincide with AB. Getting my point? So that way I have considered the cases and I have added this. Okay. Next question. Say this question. Take a convex octagon. Now the first question is, what do you mean by convex octagon? There are two things you must remember. One is called concave polygon. Another one is called convex polygon. What do you mean by convex polygon? Convex polygon means that all the angles of the polygon are less than 180 degree. All the angles of the polygon are less than 180 degree. And for the concave polygon, at least one of the angle will be greater than 180 degree. So have you now understood what is convex polygon and concave polygon? Now in our question, they have given convex octagon. It means all the angles of the octagon are less than 180 degree. Okay, let me see. Let me just give you one example so that you can understand this thing better. Suppose if I say there is a quadrilateral. A quadrilateral is what? It's a bounded figure by 4 lines. Let us say these are the 4 lines. Now observe carefully. Now you will understand better. Okay. Now this is also a quadrilateral because it is bounded by 4 lines. But you observe this angle is more than 180 degree. This means that this quadrilateral is a concave quadrilateral. Right? In contrast to that, a convex quadrilateral will be something like this, which we are familiar with. Right? So, in our question, let me erase this. So in our question, we have been given there is a octagon which is convex. So let me just draw the octagon first. 1, 2, 3, 4, 5. Octagon means there are 8 vertices. 6, 7 and 8. So let me just add all the sides of the octagon. Now let us read the question. In which no 2 diagonals are parallel. In which no 2 diagonals are parallel and no 3 are concurrent inside the polygon. Okay. Find the number of intersection points of the diagonals. This is a major thing that they have said. You have to find out the number of intersection of points of the diagonals which are lying inside the polygon. Is it clear? Let me draw some diagonals over here to make this thing more clear. Let me just join this diagonal let us say this diagonal, again, this is also another diagonal, and a lot of more diagonals are there. This can be one diagonal, this can be another diagonal, and all these things, okay? Now, please observe carefully. If you consider this diagonal and this diagonal, you see the point of intersection of these two diagonals is lying inside this octagon. Am I correct? Even if I choose this diagonal and this diagonal, again they are intersecting at a point which is very much inside the octagon. Now, if we choose this octagon, this diagonal and this diagonal, you observe carefully, they are meeting at a point which is one of the vertex of this octagon. Yes or no? These are the two diagonals which are meeting one of the vertices of this octagon. Okay. Now, if we choose these two diagonals, this diagonal and this diagonal, you see, they are going to meet at a point which is outside the polygon. Is it clear? So what we have seen, that the diagonals, if we consider two diagonals, they are meeting at some point which is inside the octagon, some points which is on the vertices of the octagon, or at some point which are outside the octagon. But in our question, what they have asked for? They have asked for how many such point of intersection are there which are lying very much inside the octagon. That's the big thing. Are you getting the point? So now, how to find it out in that way? How many number of point of intersections will be there which are inside the octagon? So let me do one thing. First task is, let us find out how many diagonals are there. How many diagonals are there? In a regular, in a convex octagon, how many number of diagonals are possible? Well, there are 8 vertices. So if I choose any of the two vertex if you choose, you are going to get a line. And how many such lines are possible? 8 points are there. Taking 2 at a time will give you the total number of lines so formed, which is 8C2. That gives us 8 into 7 divided by 2. So there are 28 such lines will be formed. Now, out of these 28 lines, there are lines which are the edges of the octagon. They are not the diagonal. You see, if I take any 2 points from these 8 points, we are going to have a straight line. Now, that line can be either the diagonal or it can be the side of the octagon. So if we subtract the total number of sides from the total number of lines that are formed, we will eventually get the number of diagonals. Therefore, the number of diagonals in an octagon will be 28 minus 8. That gives us 20. So 20 such diagonals are there. Is it clear? Now, from these 20 diagonals, if you choose any two diagonals can be chosen in 20 C2 different ways. 20 C2 will be the total number of diagonals, two diagonals chosen at a time. And if you choose two diagonals, definitely you are going to get a point of intersection, because these two diagonals are always meeting at a point. But the problem is, we will definitely get how many number of points of intersection then? It will be 20 C2. That's no doubt about it. But the point is, we want those point of intersections which are lying inside the octagon. Inside the octagon. Because all these 20 C2 point of intersections will be, some points will be inside the octagon. Some points will be on the octagon and some points will be outside the octagon. But we don't want those points of intersection. We want only those points which are strictly lying inside the octagon. So in that case, what to do? What to do? Think about it. Is it possible for us to find out how many points of intersection of these two diagonals will be the vertices of this octagon? At the same time, we have to find out how many such points are there which are lying, the point of intersection are lying outside the octagon. And if we subtract those two values from this value, we are going to get the number of point of intersection which is lying inside the octagon. But practically, I think it is not possible. You can do it, you can try it at your home, but in this case, we will not try this problem in this way. It is unnecessary creating problem. But one unique logic I can give you. An unique logic I can give you. See this one. I want the point of intersection which are lying inside this octagon. Now, we all know one very important thing. That is, for any quadrilateral, if you join their diagonals, then that diagonals is going to meet at a point which will be very much inside the quadrilateral. Is this logic clear to you? If I consider any quadrilateral, and if we choose the two diagonals will be there. For any quadrilateral, there will be two diagonals. Now that two diagonals are going to intersect at a point which is very much inside the quadrilateral. This logic we will use in this problem. Check it out. So my task is to simply find out how many number of quadrilaterals that can be formed from these 8 points. How many number of quadrilateral can be formed from these 8 points? Because the moment we find out how many number of such quadrilaterals can be formed, you can easily say for every quadrilateral you are going to get the point of intersection of the diagonal. The diagonal of the quadrilateral is definitely a diagonal of the octagon. So those point of intersection will be lying inside the quadrilateral, means it is lying very much inside the octagon. That's the logic. That's the logic. So you will simply find out how many number of quadrilaterals you can form from these 8 points. So naturally, for a quadrilateral, I need 4 points. Out of this 4, we need 4 points, but we are having 8 such points because in an octagon we are having 8 vertices. So the total number of quadrilaterals that can be formed is nothing but 8C4. 8C4 is the total number of quadrilaterals formed. And for each quadrilateral, you are going to have one point of intersection of the diagonals of the quadrilateral, which is eventually the diagonal of the octagon. And all those point of intersections will definitely lie within the octagon. Tell me yes or no. Unique logic. Okay? So, my answer in this case, that is the total number of point of intersection of the diagonals, will be 8C4, which are lying very much inside the polygon. Is it clear to everyone? Absolutely. It's a very important question. Try to remember this. Let's move for the next problem. There are 11 points on a plane, out of which 5 are concyclic. Concyclic means through these 5 points, only one circle can pass. Other than this, No 4 points are concyclic. And our question is, find the maximum number of circles that can be drawn so that each contains at least 3 of the given points. Now we all know that through 3 points, you are always going to get a unique circle. Through 3 points, you are always going to get a unique circle. So let me do one thing. Same thing as we have done for the straight lines. There are 11 points, out of which 5 are concyclic, right? Let us assume no 3 points are concyclic. I mean, no 4 points are concyclic. I'm sorry. No 4 points are concyclic. Okay? Now, if it is so, then total number of circles that can be drawn is 11C3, because through 3 points, we can always draw a unique circle. But since these 5 points are concyclic, if these 5 points would have not been concyclic, then how many number of circles you can draw? You can draw 5C3 number of circles, which actually is involved here, which is actually not formed. So I have subtracted that circles from the total number of circles formed. But through these 5 concyclic points, 1 circle will be drawn. So we have to take that 1 circle in our consideration to find out the total number of circles so formed. Therefore, the total number of circles that will be formed will be 11C3 minus 5C3 plus 1. So let me just calculate this. 5C3 is same as 5C2. So this thing goes off. This is 3. So we are actually having 55 into 3 minus 10 plus 1. So this is coming like 165 minus 10 plus 1. That gives us 155 plus 1. That is 156. Yes or no? So these are the total number of circles that can be formed, where out of this 11 points, out of which 5 are concyclic. Is it clear to all? Have you understood this? Okay, let's move for the next problem. Find the number of diagonals of a dodecagon. Dodecagon means it is a polygon of 12 sides. Polygon of 12 sides is what called your dodecagon. Okay. So my question is, for a dodecagon, there are 12 vertices. That is, there are 12 points in the plane, so on. Okay, there are 12 points. Now the question is, find out the number of diagonals. So what we will do, we will simply find out how many number of straight lines are formed from these 12 points. To draw a straight line, you need 2 points. So total number of straight lines that can be formed is 12C2. Tell me yes or no. 12C2 is the total number of straight lines so formed. So this is the total number of straight lines. Now these straight lines can be either the diagonal, or it can be the side of the dodecagon, because no other, straight lines are possible. Either the line is a diagonal or it's a side of the dodecagon. Nothing else. Now, in a dodecagon, how many number of sides we have? 12 sides. So if we subtract the total number of sides from this total number of straight lines so formed, will give us total number of diagonals. Tell me yes or no. So total number of diagonals so formed will be 12 into 11 over 2 minus 12. So that gives us 54. So there are 54 such diagonals possible in a dodecagon. Is it clear? What I have done? First, I have considered We are having 12 points because it's a dodecagon. Dodecagon means it's a polygon of 12 sides, means it is having 12 vertices. So 12 points are there in a plane. Now we are choosing 2 at a time to get our straight line. How many number of such straight lines can be formed? It's 12C2. It's 12C2. Now these straight lines can be either the diagonal of the dodecagon or it can be the side of the dodecagon, right? So if we subtract the total number of sides of a dodecagon from this total number of lines formed, we are going to get the number of diagonals. So that's exactly what I have done. 12C2 minus 12. 12 is the total number of sides of a dodecagon. So you have subtracted and you got the answer as 54. Is it clear to everyone? Absolutely? Okay. So let us move for the next problem. Answer is 54. Find the number of sides of a polygon whose number of diagonals are 44. Okay. Okay. Let us say it is a n-sided polygon. Now, if it is an n-sided polygon, how many number of diagonals can be formed? But before that, you find out how many number of straight lines can be drawn. N-sided polygons means we are having n vertices. So total number of lines so formed will be NC2. So these lines are the combination of either the diagonal of the polygon or it will be the side of the polygon. Now for an n-sided polygon, we are having n sides. So if we subtract n sides from the total number of straight lines formed, we are going to get the number of diagonals. And they have said the number of diagonals is 44. So let me just solve this equation to get the value of n. N square minus n minus 2n is 88. So it's coming like n square minus 3n minus 88 is 0. So n square minus 11n plus 8n minus 88 is 0 implies n minus 11 plus 8 n minus 11 equals to 0 gives us n plus 8 into n minus 11 equals to 0. So either n is minus 8 or n is 11. But n cannot be negative. Therefore, n is 11. That is, it is a 11-sided polygon. It is a 11-sided polygon. Is it clear to all of you? Have you understood? So what we have learned? We have learned that for an n-sided polygon, remember this as a formula. It will be needed. Because, in the examination hall, we will not be able to, calculate all these things again and again. Because every time you have to think that logic and you have to do no. Straight away, remember the formula. For our n-sided polygon, the number of diagonals will be NC2 minus n. That's exactly what I have said. And we have understood the logic at the same time. So remember this so that we can solve those kind of problems easily. Let's move for the next problem. This question came in JEE Advanced 2016. What they have said? Let n is greater than equals to 2 be an integer. So n is an integer which is greater than equals to 2. Take n distinct points on a circle. Okay. So there is a circle. And on that circle we are having n points. These are the n points. It is going on. So these are the n points. And then what happened? Color the line segment joining every pair of adjacent points by blue. Okay. So what they're saying is, actually, if you join those lines, okay, you are actually getting what you are getting. You are actually getting the edge of the n-sided polygon. And they have said to color it with blue. And the rest by red. Rest by red means any other than this adjacent sides, you join any point, it has to be filled with red line. Means this line will be filled with red. Suppose there is one point here. This will be red. This will be red. Everything will be red other than the adjacent sides. That is, in one word, what they are saying, that your diagonals are in red color and your edges or sides are in blue color. That's it. Now what they are saying. If the number of red and blue line segments are equal, okay. The number of red and blue line segments are equal, then find the value of n. See how simple sum they have given in JEE Advanced. If you know the logic, it will not even take 50 seconds to solve this sum. So this kind of problems also comes in JEE Advanced. It's not that JEE Advanced means you will all get, a very, very tough problem which you cannot think. Yes, there are some problems where you have to use your, intellect. At the same time, time-consuming thing is there. But not all the sums. See this sum? Is this sum difficult? No. If somebody knows the fact of the diagonal and sides of a polygon, he can solve this at ease. I'm telling you. Tell me, what is the total number of diagonals of an n-sided polygon? Obviously, the total number of diagonals just now we have done, it is nc2 minus n. And what will be the total number of sides? Total number of sides of an n-sided polygon is n. Now, by the question, they have said nc2 minus n is equals to n. That is, the number of red and blue line segments, they are equal, they have said. So these two are equal. So simply from this, we are going to solve for n. That's it. That's the problem. So this can be written as n into n minus 1 over 2 is 2n. That gives us n into n minus 1 is 4n. We can cancel n from both sides because your n cannot be 0. So n minus 1 is 4. That implies n is nothing but 5. That's it. That's your answer. Is it clear to everyone? See how simple it is. There is no word to say. You cannot say that, sir, it is a tough sum. Even you cannot say this is an average sum. In my opinion, it is below average sum. And I hope you people will also accept this. Still, this is a sum came in JEE Advanced. Okay, let's move for the next one. See this question. There are 6 circles and 8 straight lines. There are 6 circles, 8 straight lines, and 4 parabolas on a plane. Find the maximum number of point of intersections possible. Maximum number. Okay, suppose if I take 2 circles, the maximum number of 2 circles, the point of intersection will be 2. But you should not consider the circles like this. Then you are not going to get any point of intersection, and that will not give us the maximum number of point of intersection. Okay. Now, again, at the same time, all these circles and all these, parabolas and straight lines, they are not of the same one. I mean, for the circles, they are not 2 equal circles. Because if there are 2 equal circles, then there will be infinite number of point of intersection. That's not the question. Here, all the 6 circles, 8 straight lines and 4 parabolas, they are all different. They are all distinct. Okay. Now, how many number of such point of intersections possible? See, we have to consider cases here. Case 1. Case 1. Just 1 second. Case 1. What is that? The number of point of intersection when circle intersects. Circle and circle. Okay. So, in how many different ways you can choose 2 circles from these 6 circles? It is 62. And for 2 circles, the maximum number of point of intersection will be 2. Therefore, the total number of point of intersection, maximum number of intersection when two circles intersect each other out of the 6 circles will be 6C2 into 2. Is it clear or not? Case 2. I am taking straight line and straight line. Now, in how many different ways you can choose 2 straight lines? I can choose in HC 2 different ways. And for every such selection, you are going to get 1 point of intersection, right? You are going to get 1 point of intersection. Therefore, total number or the maximum number of point of intersection you will get for 2 straight lines taken at a time is HC2 into 1. Case 3. We are taking parabola and parabola. So let me take 2 parabolas from these 4 parabolas, which can be chosen in 4C2 different ways. And 2 parabolas can intersect each other maximum at 2 points. So total number of point of intersection will be 4C2 into 2 for these 2 parabolas taken at a time. Okay. What are the cases? Case 4. It is, now we are taking a circle and a straight line. Circle and a straight line. Now you choose 1 circle. In how many different ways you can choose from 6 circles? It is 6C1. Now you choose 1 straight line. In how many different ways you can choose 1 straight line? It is 8C1. Now for a single circle and a line, the maximum number of point of intersection will be 2. Because 1 circle is here and 1 straight line is there. So maximum number of point of intersection will be 2. So total number of such point of intersections will be 6C1 into 8C1 into 2. Is it clear? Case 5. Let me take circle and parabola. Think about it. Now for a circle and a parabola, they can intersect maximum at 4 points. Let us say this is a circle and this is a parabola. So they can intersect at maximum 4 points. Is it clear? Okay. So now there are 6 circles. In how many different ways you can select 1 circle? That will be 6C1. And there are 4 parabolas, out of which we have to select 1 parabola, which can be done in 4C1 different ways. And for each such selection, there will be 4 point of intersections. Is it clear? There will be 4 points of intersection. Therefore, the total number or the maximum number of point of intersection that you will get from a circle and a parabola is 6C1 into 4C1 into 4. Okay, let us consider case 6. Here we are taking straight lines and parabola. Now, for a parabola and a straight line, maximum number of point of intersection can be 2. Therefore, the total number of point of intersection will be, first we have to select in how many different ways I can choose 1 straight line from these 8 straight lines. That can be done in 8C1 ways. And for a parabola, it will be 4C1 ways. And for each such selection, there will be 2 point of intersections. Therefore, the total number of or the maximum number of point of intersection that you can get from a straight line and parabola is 8C1 into 4C1 into 2. I hope it is clear to all. Now let me just calculate this. 6C2 is basically 6 into 5 divided by 2 into 2. So that gives us 30. 8C2 is 8 into 7 divided by 2. So that gives us 28. 4 into 3 divided by 2 into 2 gives us 12. 6 into 8 into 2. So that gives us 96. And here it is 6 into 4 into 4. That is again 96. This is coming to 8 into 4 into 2. That is 64. Is it clear? Therefore, the maximum number of point of intersection will be what? It will be nothing but adding all those cases, that is 30 plus 28 plus 12 plus 96 plus 96 plus 64. So how much it is coming? This thing gives us 40. 40 and 30, that is 70. 70 plus, this is, last one is 64, and this is 192. So we are actually getting 6, it is 2, and then 2 is remaining, so it will be 326. Am I correct? So total or maximum number of point of intersections that you are going to have is 326. Is it clear to everyone? Okay, let's take the next problem. Now, there is a conception. Before going for a problem, there is a conception. It states that if there are n straight lines drawn in a plane such that no two of them are parallel and no three of them are concurrent, find the number of parts into which these lines divides the plane. Have you understood this? There are n lines in a plane. Now these lines are dividing the plane into halves, into some areas. So you have to find out how many such areas or how many such divisions or how many such parts of this plane can be formed. Is it clear? Now, let us consider that n is 1. That is, there is only one straight line. Now you tell me, for one straight line, how many number of parts formed of this plane? 2 parts. So number of parts formed is 2. Okay. When n is 2, what happened? Let me see. In how many parts it has been divided, the plane? It has been divided into 4 parts. Yes or no? Yes. So it is 4 parts. You see, actually we are trying to find a pattern, because as I told you, every time I say that mathematics is all about pattern. Your main task is to find out that pattern. In this question also, I'm trying to do the same thing. If n is 3, then let us see if n is 3. Let us say this is one line, this is another line, this is another line. So in how many parts this plane has been divided? 1, 2, 3, 4, 5, 6, and 7. So it is coming to 7. So how can we relate this? Okay, so this is 4. So can we write in this way? 1 plus 2. Here it is 7. I can write this thing as 1 plus 2 plus 3. Look it very carefully. Okay, here n is 3. I've written this thing as 1 plus 2 plus 3, and 1 is separated. Okay, I'm trying to relate this thing with this n. Here is 2. I can write this thing as 1 plus 1. Okay, so let me just check the last one, and then we will go for directly derivation of the formula. If n is 4, then what will happen? 1, 2, let us say this is 3, and let us say this is 4. Okay, so now these, if I produce, they are going to intersect at that point. If I produce these two also, they are going to intersect at this point. Okay, now please see this one. How many number of parts this plane has been divided? Please check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Yes or no? So this plane has been divided into 11 parts when n is 4. So when n is 4, answer is coming to 11. It means, can we write it in the previous pattern? 1 plus 1 plus 2 plus 3 plus 4. Check it out. Is it clear? So have you understood the pattern? Now if I ask you that there are n lines there, now in how many parts this plane has been divided by these n lines? What you will say? You will say, sir, it is divided into 1 plus 2 plus 3 plus till n. So much of parts of the plane will be formed. And the total parts formed is what? 1 plus n into n plus 1 divided by 2. So that gives us how much? It gives us, if I take the LCM, it is something like this. So this much of parts of the plane has been formed. Yes, that's the answer. So have you understood this? So what is the total number of parts that this n lines has divided this whole plane? It is n square plus n plus 2 divided by 2. That's it. But before remembering the formula, try to understand the logic. See how I have used to derive the form simply by observing the pattern so formed. Clear? Let me take one example on this. See this question. N straight lines are drawn in a plane such that no two of them are parallel, okay, no three of them are concurrent, fantastic, such that this line divides the plane in 67 parts. They have already said that it has been divided in 67 parts. Then find the number of different points at which these lines will cut. What happened? Let us assume that there are n such lines. Now this n lines has divided the whole plane in 67 parts. And we know the formula that n square plus n plus 2 divided by 2, that is equals to 67. So from here can we find out n? Yes. So it is coming like n square plus n minus 132 equals to 0. So now if I solve n, what we are going to have? Factorize it. So simply go for middle term breaking. It will be n square plus 12 minus 11n minus 132 equals to 0. So that gives us n square plus 12n minus 11n minus 132 equals to 0. So n plus 12 minus 11n plus 12 equals to 0. So n plus 12 into n minus 11 equals to 0 implies either n is minus 12 or 11. Minus 12 not possible. Therefore, your n is 11. Is it clear to all of you? So we got that n, that is the total number of lines that are on the plane such that the plane has been divided into 67 parts, are 11. Is it clear? Now read the question. Find the number of different points at which these lines will cut. We are having 11 lines. So how many number of point of intersection will be there? It will be nothing but 11C2. We have done this thing a lot of time. So 11C2 actually represents the number of ways of selecting two straight lines. And two straight lines is always going to intersect at one point. So the number of point of intersection from these 11 lines that you will get is 11C2 only. So that gives us 11 into 10 divided by 2 gives us 55, and that will be your answer. Is it clear to everyone? Have you understood this conception? So this conception is very important. First you understand the logic, then you remember the formula, if possible. If not, then ultimately you have to do it in the exam hall and you have to use your logic there. So I think it's better to remember after knowing the actual fact behind it. Is it clear to all? So that's all for today's class. See you very soon in my next class on combinatorics. Till then, stay tuned to us and don't forget to subscribe, like and share the video to your friends. Thank you so much and take a very good care of yourself. Hello students, welcome back to my channel. It is always pleasure to be with you. I hope you have all seen my previous videos on combinatorics. Today we are going to start our fourth session. And in this session we are going to cover